I guess we'll get the ball rolling here. So, good evening, everyone, to our October 2025 AF Mixer meeting for SOAREX. Right off the bat, I'll read out our little preamble here. Please note that all of our meetings are recorded, made available to the public for viewing on our YouTube channel. By participating in the meeting, it is understood that you have accepted said terms. So,
well, Ken will be proud of you.
Yeah, with that out of the way, speaking of which, we have some regrets for tonight. Ken, now you're sharp, Peter. Yeah. Ken, Charlie, and Dave are all
Howard.
Recorded regrets.
And Howard.
Howard as well. Okay. Yep. So they will not be with us tonight. So this may be the crew by the looks of it. So. Anyway, so does anybody have any additional topics that they want to discuss outside of the roundtable, or anything, any urgent news to bring up? Now's the time. Any additional agenda items? Going once, going twice. Nope. Okay. So I guess we will dive right into Michael, if you are ready to give us a little update on your antenna switching project. When did you do the first discussion on this? Do you recall?
2023.
Okay.
I was
looking.
that was what we did, and then we now progressed a bit till I actually have a working switch, which is really good. So anyway,
okay.
Let me share my screen here. There, okay.
Just remember to mute your mics, everybody, if
and
you have any unwanted background.
Entire screen. Well, that didn't work. Maybe. No, that didn't work. Try again. So let me see. Okay, my presentation is up and running. Where am I going here?
Is it so it's the third button from the left, and then
I got to try again here. Okay.
When you get into the screen,
share screen,
click on entire screen.
Yeah, I got it. Okay.
And then click on your presentation window.
Oh, I got to
click on share.
Yeah.
There's my presentation. I'm looking at it now.
Okay, click on it.
Yeah, I did. It's there.
Down to the bottom there and click on share.
Yep. 3-step process.
Peter,
have we established that window doesn't work?
Window works, actually. I'm going to use window.
Yeah, it's a little cleaner.
It's still the same thing. You click on the window and then you click on share.
Okay. Yep. You see it now?
Perfect.
Okay, good. So now, does this give me the ability to use pointers? Yes.
Yep, it's looking good.
Okay, you can see the pointer. Okay, good. All right. So this is part 2. Daniel Goodyear, who I thought might be here tonight, and I had worked on this switch a year or so ago. So this is an update, more or less. So yeah, this is the background that in 2006, only 19 years ago, a bunch of us built a remote antenna switch based on a design from QST, and we actually built 8 switches altogether based on the design. And in 2023, merely 17 years ago, Daniel and I built an automatic antenna switch, and that was driven by the need to make sure that when we were using our radios and switching bands, for example, an FT8, that the radio, the antenna rather, followed the antenna on the tower. The antennas on the tower followed the radio. So that was what it was all about. This is the design of the switch on the tower, and there's internally, there's 6 relays here, here, and here, and they switch. These are the connectors on the outside. They switch from the center connector here, which is the transmitter connection, to whichever antenna you happen to have selected. And the relays are diode protected for surges. And when a particular relay is not energized, then the relay grounds the antenna connection. So that's a source of protection, I suppose. Also got lightning protection, of course, but the idea is that when the relays aren't energized, the coax connection is short. Center is connected to the shield. One of my criticisms of this device is that there is no there is no similar thing for the transmitter connection. So there's, whether the switch is live or not, the transmitter connection, this one in the middle here, is not grounded. So that's just that means your connection to your radio is not grounded when your switch is off. But anyway, so that's the switch. This is what it looks like inside. This is sitting on my tower. So I started, when I built the switch, my original switch, I put in this is my crude experiment with KiCad. I put in, these are two wafers on a switch, and one of them just lights up an LED whenever you select the particular antenna here, and the other one provides DC from the internal switch in the radio room here out to the switch on the tower. So that's the switch, and notice my excellent job in lining up the LEDs. This one, almost perfect. Anyway, so why do this? Well, we wanted, as I said, we wanted to make sure that we didn't connect the wrong antenna to the transmitter, and we did it using the transceiver band data output, and that's designed. The intent of this band data output is band output data's connection on the back of the radio is intended to drive a linear, so you can control the band the linear's on. Anyway, so we started with a breadboarded circuit, and then that was in 2023, and in the meantime, we built a working switch with and put it in an enclosure. The main thing was putting it in an enclosure and making sure that everything worked. So for what it's worth, here's the block diagram. There's the transceiver. It's got a BCD decoder. The FT1000 and the ASU transceivers use BCD data to drive the outputs on the connection on the back of the radio. Likewise, the Alcraft K3 does. The K series do. So basically, the transceiver is connected to the decoder. Decoder is connected to a relay board. What that relay board does is put 12 volts up a cable to the appropriate connection switch on the tower. And the relay board also drives an Arduino, which drives the display. So there's stuff in the box to drive that. And we started out with the original manual switch I showed you, and we started thinking that what we do when we put this in an enclosure is we'd have a switch on the thing that would manually select the particular antenna by bypassing the decoder and stuff. Then we realized that we could do this from the Arduino software, which is what we've done. So, oops, wrong way. So on the back of the FT1000MP, this is this picture here, down here at the bottom left, there's the 4 band data outputs, and they are either 0 or 5 volts, depending on whether, if 5 volts of the band has been selected, it's 0, various combinations. The 5 volts of the particular band has been selected, or 0 if it hasn't been. I'll come back to that in a minute. It looks like you can only do this with Yaesu or L-Craft transceivers. I looked at the Kenwood. I forget what it was. Yeah, I think it was the Kenwood, and it appears they don't do this. So what they do is they have other manufacturers have various voltage levels to drive the linears, but that doesn't allow you to, in some cases, pick a particular band. You can say, well, it's 80 and 80 or 40, but you can't say it's just 80 or just 40. It would appear. So I'm glad I've got a Yaesu. So what the BCD decoder does is it takes these outputs from this thing, from the radio, and picks up and connects these on here. There's all the bands going from 160 right down to 2. So depending on if your radio is sitting on 17 meters, then this point here goes high. That's right. Yeah, it goes high. That's right. And no, sorry, it goes it's sitting high. All these are sitting high to start with. When you select a particular band with your switch, this on the back of the radio, this if it's 17 goes low to ground. So this is the logic table for the BCD14, which is the particular model. So for example, 40-meter antenna points A and B are at 5 volts, C and D is 0, and likewise 20, A is 5 and C is 5, and the other two are 0. So that's how it's done. So you need the decoder to build the automatic switch. You need the decoder. You need a relay board to drive. What this does is provide 12 volts to the remote antenna switch through the cable that goes up to the tower. And you need an LCD display, we decided, and you need this N154 module to provide 5 volts to drive the LCD display rather than the 12. So all this does is switches from 5 to 12 to 5, plus connectors and all that other stuff. So this is looking at the bottom. Okay, we designed the switch. We got an enclosure, Hammond enclosure, the right size, and we went through an exercise of actually buying the wrong boxes, which were too shallow. We hadn't realized how much vertical space we needed. So these boxes are, I think, 3.5 inches high now, and there's 2 levels to the box, and they're held. This is the thing with a plexiglass plate, and these are the 8 relays, of which we're using 6 because for antenna control, because there's only 6 relays on the external switch on the tower, and basically you give it ground, and if these relays have normally open and normally closed contacts, so if the particular relay is selected, it puts 12 volts. If it's K1, it puts 12 volts here. Here, this one. And that means 12 volts goes to this output terminal, and you connect your cable from the external switch on the tower to this point. And there's a ground here someplace as well. So that's what these 6 are all about. And these 2 are for other things. One of them is the automatic manual control. The other one, I forget what it is. On the bottom here, there's a set of terminals that you connect the BCD decoder to. And when the particular antenna is selected, the pin on the BCD decoder goes to 0, and that takes this terminal to 0, which is what turns on the relay. These are these 154 things, and what you do is you give it 12 volts on this side, and if you connect 5 volts to here, it's an active high thing as well. Then if this particular relay is selected, it goes to ground. This point goes to ground, and that tells the Arduino what to do, what to display. So back here, that's the lower board. Sitting higher up on the second level is this one, and this has got the BCD decoder here. it's got the Arduino, and it's got a set of control relays. There's 4 of these here, and they drive the drive their Arduino and whatnot. So this is what it looks like from the top with both boards in place. The lower board is underneath. On the back, there's the antenna connector, the cable going up to the antenna. This is a 15 pin, I think it was, serial cable, and the power pole connection here. And the board here was a nightmare wiring because it's really tight. The board has traces that go from the top to the bottom underneath, and you just connect what you need and all the other wiring. It turned out to be not very straightforward getting that organized and determining whether or not I had shorts or whatever. Anyway, that's what it looks like from the top, and the other board is below at the bottom of this standoff underneath, and on the front, on the left-hand side, there's an on-off switch. Daniel has a heater switch to drive his heater, and it sits in here at the same level as this. On the right-hand side, there's an automatic to manual push button switch, rather, and then underneath is a little, beside it, there's a little push button that allows you to automatically control the antenna, switch from one antenna to another if it's in manual mode. So this is another picture of this from the side. You can see the 2 levels now, and this is Daniel's box. So on-off switch, his heater control. On the right-hand side, the automatic to manual on-off, and this is the push button. And here, this is the layout for this is masking tape, of course, to allow me to cut using a nibbler to cut the holes in the board for the display. And we used Greenlee punches to drill the 1/2 inch holes for these things and a 1/4 inch for this one. And the tape here is to prevent things getting dropped onto the board by mistake. And you can see the relays on the bottom, and the 154 is the 2 of them there. And these are the connections to the antenna switch on top. So on the back, here's the 9-pin Molex for the connection to the external antenna switch. And here's the connector for the radio connection, and with the pins. This is a really handy device. You don't have to solder anything. You just connect things to here. There's the power pole. Here's another picture of the same thing. Now I've got the hole cut. There it is, lit up nicely by something in the back. I guess it's actually connected or something. I'm not sure what that is in the back. Something's lit up anyway. Nice, pretty picture. Here it is with all the stuff in it. You can see the 4 relays, all the wiring and everything's all done. And this is the back view with the these are labeling things. I just labeled it with a Brother labeler. Couldn't be bothered to. The other way to do labeling is to actually get a piece of transparency and in a Word document, perhaps to space out the text in bold or whatever, and then you basically cut the thing to the right shape and just stick it on your enclosure and cut the holes where stuff needs to go. One of the issues with this connector to the radio is there's no way to fasten the DB15 properly to this, because you can't get at the holes because they're behind to mount it properly. So my connection comes loose from time to time. And these are not straight because you have to use a nibbler to do it. Difficult to get it exactly right. So this is my radio sitting on 12 meters, and this is what the switch looks like. This is my completed switch here. It's on. It's not in manual mode because this is off, and it says auto. The display says auto or manual on the first line, and second line tells you which antenna it is. So this is my mini quad, 10 through 20 mini quad. This is another. Now it's in manual mode. I pushed the manual button, and it's for my R7. And yeah, so depending on which antenna the second line shows, it's the R7 or it's the Hemstick pair or it's the 80 meter antenna, whatever it happens to be. But you have to use it in manual mode to do that. You can do if you need to. Now I have two 40 meter antennas. One is a R7 and the other is a DXB. Both do 40. So I had to pick one to put into the automatic mode, and it was the R7, but you can also pick it in manual as well. So this is how it started. This is what it looked like to start from the breadboard and the finished product. So yeah, so that's what I have to say. It worked. We're very pleased with it. I've done mine. We have yet to do Daniel's. Daniel's been very busy, so hopefully the next couple of weeks we're going to do his, and then we'll be done. Long project, but it works. Now, any questions before we go back?
Okay, we've got Peter. Please go ahead.
Yeah, very interesting, Michael. Must have not a bad presentation, because I had down about 5 questions and you eventually answered almost all of them. So, but a couple of things. The manual mode, just make sure I understand. So you push the manual mode button to cycle through the various.
No, how it works. If it's in manual, you push the manual button to put it into this one here, to put it into manual mode, and this lights up. So now you're in manual mode. So the radio is not controlling where which antenna you connect. So then you use the push button. You hold the push button down for maybe a quarter second or something, and it switches.
Okay.
Hold it down, it switches, and you push it again, it switches a second to the next radio, next antenna, and so on. And it tells you which one. It says manual. It tells you which antenna.
And then the Arduino's doing that switching.
That's right. Yeah. Yes, that's right. The Arduino is doing it through the. Yeah, that's right. It is. I have to think about exactly how, but that's right. So the programming allows you to do that. It's been set up that way.
The BCD decoder, was that a kit, or did you get the board made and you just?
No. It's. I'll go back. Let me go back to it. I'll go back there. Yeah, this is actually it. I didn't make it. It came this way. It's all done. It's from Microsystems, I think it's called. I have to get the company name, but it's all done, and you don't have to do anything. All you do is you connect from whatever control you're using. The A and the B and the C and the D outputs from the back of the radio basically get connected appropriately here. Mm-hmm. And then depending on which combination of pins are live from the radio, it sets up one of these. Okay. That's the output.
Well, I guess you're allowed to build a kit every once in a while.
Yes, that's right. But anyway, this is not a kit. I'm glad it's not.
Yeah. Oh, very good. I think that covers it for me. Oh, the only other thing I didn't really pick up on. I thought that was a really nice case that you had made, but that was a Hammond case that sits on top of the tower, is it?
Oh, which one? The one at the beginning. The one at the beginning, you mean? This one. This here?
Yeah.
This one. Oh, this is I forget where we got the case, but the kit. This was a kit. The switch itself is a kit. So it gives you they give you the 6 relays and whatnot, and you just I forget if I had to mount the relays or not. I don't remember. But
so is there weatherproofing on the inside of that case?
No. It's just there's a drain hole somewhere at the bottom. I think I guess it would be on the bottom down here somewhere, and doesn't seem to need it. I don't think I sealed it either. I don't remember, but this has been up since 2003.
Okay.
It works fine. What I did to put the connectors to connect the coaxial cables, what I've always done is you put you have your PL259, you put it on, and what I use is this M130. It's the flexible, beautiful rubber thing that it's stretchy, and you stretch it and it goes a bit narrow, and you wrap it around you put your PL259 on, tighten it up, you pull this stuff, and you just like you use with electrical tape, you put a couple of turns around it, and it shrinks onto the over the. You make sure you cover the PL259 and the part of the SO239 that's exposed, and then after that you put a few turns of that on, make sure it's completely covered, and then after that you put a good quality electrical tape on top of it. And it's really very good, because when you do it that way, you can come and cut these things. You can cut one of these things off, and it's pristine underneath. It looks like new. There's no water gets in or anything. It's really good. Though I've always done that.
Okay, I think. All right, good. Thank you, Michael.
Yeah. Okay.
Okay. Sherry, there we go. Please, you're up.
Yeah, thanks. So where did you get these aluminum sheets? For example, the one behind that cabinet, right?
What, this here? We look at the same.
The other picture, the first one.
This one.
Yeah.
Oh, this is the box. The box comes this way, like it's a Hammond box or something, aluminum box.
Okay, but behind that there are two aluminum bars, right?
Oh, these.
Yeah.
I bought them from Metal Supermarket.
Oh, is it? Okay.
They're I don't know, maybe 1.5 inches by a quarter, maybe, and
Okay,
they're just used to. You can see here. This they're held on. They're held onto the tower leg with U-bolts, one here and one here. So it's just screwed into the bottom of the box. It would be here, I guess. Yeah.
So you bought the cabinet from Hammond. It's a Hammond box, and then
I think so. I think I don't. So long ago, I don't remember. I think it probably was a Hammond box. We got the box. It had to fit. What had to fit in it was this thing here, and we had to line up the centers of the holes appropriately to line up on the board.
Okay.
I have in my other presentation. I went into some trouble to show how that worked, but
yeah.
Basically, we had to make sure that the holes for the SO239s were centered properly, so that when the kit that you got, the kit came from Far Circuits.
Oh, I see.
Which is a company that provides kits, and they're still available. And I bought the relays separately from an American company, and that was interesting because, yeah, and then we put the whole thing together. We made a little template to make sure you could drill the holes in the exactly right places. I used a greening punch to do it. It all lined up very well. The relays came from the States, and that was an interesting exercise. I bought about 80 of them. Well, yeah, there were 80 relays altogether. I think I forget now. But the company wanted to know, was I an incorporated company or not? They wanted to sign all kinds of paperwork swearing that I would never sell these relays to China or whoever. And it took a bit of convincing, but eventually realized they were convinced that's fine, and told them what it was for, and it was okay. But I guess these things are restricted. They're 12-volt relays, common garden relays, but I guess they're treated as secret stuff or something anyway. So that's where the parts came from, and everything had to be lined up exactly right to make sure that things went together. And how I did that, I cut a piece of aluminum sheet, drilled the holes in the aluminum, which gave me a place to center the drills drill bit to get the holes in the right place, and it worked out reasonably well.
It's probably the relays that you ordered that got them curious, I would think.
No, that's the relay. It was an order of relays. It was a lot of relays because there were 8 of us. It must have been 50 out of it. Eight sets. How many people did I say we had here? I forget, but it was a lot of relays. 50 maybe it was. I forget now. But they wanted me to say, did I actually have to, in the end, have to fake it and say I was a company? I forget now. But they would not. They wanted some indication of who I was and whatnot, which I thought was interesting.
Michael, it looks like the relays are the main part of that. Like you said, it was a kit. So what did the kit comprise of?
The kit was the
plate.
The plate. I can go back to the other presentation if I can find it. Hang on.
Yeah.
Let me just do that.
Put it in trouble, but
no, it's no problem. Let me just do that. Let me go back and see if I can find it. Can I do it this way? Let me see.
Because it looks like you supplied the SO239s.
Oh yeah, we supplied everything, SO239s and everything else. Yeah.
Yeah. So not too much to the kit, so to speak.
Yeah, the kit was. I can't go back. I'm not quite sure why. I don't have the presentation here to go back.
That's okay.
But yeah, let me get rid of this. So the kit was, I think it may have had, I forget whether it had the board, and I may have had to put the diodes in as well. But anyway,
right.
I don't think we had to cut the board or anything. I don't remember.
You have like 7 antennas outside?
Yes, I do. I'm going to stop sharing here. Yeah, I've
seen his backyard with my eyes. It's impressive.
Okay, cool.
Yeah, I've got on the. I got a picture here someplace. I might have.
Sherry, do you know when you drive through a random neighborhood and you see a whole bunch of antennas in the air? That's Michael. So.
Well, not really. I've got what I've got on.
We got an antenna switch for 6 antennas. That means Eric is right for a change.
Cherry, have you ever seen that 08, that's been on the cover of QST? It's kind of what Michael's backyard looks like. The 160 meter beam in Norway.
I got a picture of that too somewhere here. Yeah, I know what you mean. I've got I have a deck and attached to the back of the house with a chimney. And in the back corner of my deck is a tower. It's a Delhi. It's got 3 10-foot sections, so it's 30 feet high. And I have a rotor. I have 2 pieces of 15-foot pipe joined with a coupler, a thrust bearing at the very top, with the Yaesu rotor controller about 6 feet off the deck, so I can get at the controller if I need to. And on the top, on that rotating mast at the very top, is the mini quad, which is a 10 through 20 3-element beam. Small. It's a 10-foot boom, and then underneath that, a couple of feet underneath that, I've got a pair of ham sticks for 30 meters, and that's on the tower. And then on the other side of my deck, I've got an R7 on the roof. It's mounted on the outside of the house to the wall, and it's on a mast that extends from the bottom from the roof of the deck up 20-odd feet to get it up above the second floor. And that's 10 through 40, but I never use it. I use the beam because it's a bit directional. And I've got an 80-meter dipole that right now, one leg comes from my tower, it goes 30-something 45 feet to the back fence and along the back fence. And the other piece goes from the tower, which is one corner of my house, and I have a semi-detached. My neighbor on the other half is very good to me and allows me to hang the other half of the antenna across his property. So it's a really hokey antenna, 80-meter antenna. And tomorrow, actually, we're going to move the leg that goes across his property. We're going to move it to the front, go to a tree in the front yard. So I'll have a reasonable looking 80-meter dipole. And what we're going to do ultimately is create a fan dipole out of that by hanging a 40-meter antenna underneath it with standoffs, like this standoffs kind of thing, and probably a 6-meter underneath. I've never used 6 meters, but it'd be interesting to try it. Yeah.
Okay. And I wonder, how much big hole would have, going into the house?
How much which?
How much you must be having a pipe or something going into the house?
No, what I did on the roof of my house, on the soffit, which is the piece underneath that comes out, where the eaves trough is, it's about maybe 2 feet wide. And what I did, I put a plate there, and that plate holds. It's a metal plate, probably 4 inches wide by 2 feet long, perhaps. And I've got a bunch of feed through SO239 connectors going through that plate, plus the rotor control cable, plus the antenna switch control cable coming through that plate. And that's on the back of my house. And on the second floor here, we've got my shack, which is right here. Across the wall to my left here is the master bedroom. And then it's the outside of the house. And I've got the coaxial cable comes into my shack, coming underneath my operating desk, which is here. You can see it?
Oh, okay.
It comes underneath. The cables go from my radio down to a panel on the bottom, up the wall, and across the attic to the outside, to that panel on the outside. And the coax comes down from the roof down to the bottom of my tower, which is 17 feet down, to the lightning arrestor box. And then the cable goes from there up to the top of the tower and the rotor and all that stuff, because I wanted to put the lightning protection at the bottom, close to the ground.
Okay.
Thanks.
Right.
Very interesting. Yeah.
Drew, please come on in.
Yeah, that was a very good demonstration or presentation, Michael. Very, very well built set of relays and the like. It's interesting that they thought they were controlled goods. I was wondering about, well, you have more than one antenna and the computer doesn't select between the ones that are there. You have more than one that is 10 meters and that sort of thing. So you have to do the manual switching for that. But I was wondering about just grounding everything. I mean, I'm putting together a 3-band relay system now for 6 meters, 2 meters, and 70 centimeters. And I'm kind of wondering about whether they're going to start interfering with each other inside the same box.
No, they don't.
If you were getting effects from your antennas from having that many connections all together.
Never had a problem.
Never had a problem.
Speaking of the first part of your question about multiple antennas, my mini quad is 10 through 20.
Yeah.
So the BCD10, the BCD14 box is designed to select one antenna, like it connects when you go from, if it's set on automatic, you go 10, 12, 15, 17, 20, it always preferentially selects the mini quad as the antenna for that, because it's all, if I want to use if I wanted to use the R7, which also has, let's say, 20 meters on it, I would have to select the R7 in manual mode. In other words, use the bypass switch to select it, and then you cycle through and you can select the R7.
Right.
That's how I do that. As far as grounding is concerned, well, my radio is sitting on the outside wall of the house. There's a ground wire that I put in through my wall down to the ground with a 10-foot ground rod. And that's what the radio ground connector is connected to. All the other cables are, well, the antennas, the lightning arrestor panel outside is connected to a ground rod. My tower is connected to the same ground rod, also 8 feet into the ground. And I've got two other ones that are connected from the bottom of the tower out to each one separately, not daisy chained. And that's how I've done it. What I have not done yet, which I probably should do, is connect the base of my tower, the ground to the base of the tower. I should connect it to the utility ground connection, which in my case comes from the panel in the garage. There's a ground wire that comes from that to my water pipe. It's a copper water pipe in the basement, right, through the floor on the floor side of the water meter, and the utility connection is there. So what I should do is connect that point to the tower ground as well. I have not yet done that. Closest I've come to problems with lightning was there's a tree on the boulevard on my neighbor's property, and it's got to be, 40 feet away. And about 20 years ago, we had a lightning strike to that tree, and it took a whole bunch of bark off the tree. It only fried my VCR, and really? My answering machine didn't touch the radios at all. They were turned off, didn't touch them. But
I would bond that tower as soon as you can to your other. You shouldn't have two separate grounds coming into your home. It's illegal for one thing, but it's also dangerous for another.
Yeah, well, I got to do that. It's one of the things I want to do. Yeah. I've got some number 6 cable. All I got to do is connect. It's already set up to connect. Yeah, so I should do that.
Yo, for sure. No.
How do you have two separate grounds? Sorry.
Well, I have the radio ground from the FTDX to a ground wire right below me now on the ground floor into the ground. That's the one connection, and the other stuff is the other, and all the other antennas go through the lightning arresters outside.
Oh, okay. So the FTDX10 has a ground underneath you, like meaning you drilled underneath?
No. It goes out. I'm looking at the outside wall of my house now. It goes out through the wall, and down the outside to a ground rod.
Oh, I see.
See, the problem that you have with that setup is, if you touch your house ground with one hand and you touched your radio ground with another hand, you're leaving yourself open for a potential difference because you have two separate grounds.
Yeah.
That's why you must bond your RF ground system to the house ground.
Yeah.
But the house ground is totally it's a separate you got a ground wire from your house. You got a grounding system that comes to your house. Now you've put your radios in, you've put some ground rods in the ground for your radios, for RF ground for your radio systems, right?
Yeah.
Your antenna, all that shit. You got a separate ground. That means you got two different ground points in your house. There. If you put a meter between those two ground rods or two ground systems, you will probably find that there's a voltage difference.
Yeah.
Yeah,
so you have to bond the two together so that they're at the same potential.
So how I'm going to do that is I have a ground outside directly beside the tower. There is a ground rod that's connected to the bottom of the tower. So what I'm going to do, the thing I need to do, the only thing I can do really, is I can connect that tower ground to my utility ground through a cable. Through the ground, the utility ground comes through the water meter in the floor of the basement. So I can bond things that way. That's about all I can do.
But yeah, Peter, another question, like, how will you bond this house ground to this one, like, to the RF ground, which we are.
I don't know if you can see it, but let me see if I can show you.
Okay.
Where am I? Oh, there it is.
Yeah.
There, I think you can see now. There's a Burndy connector up there.
Yeah.
Yep.
Where I've ran my RF ground into the house, over into the main ground, because I got my panels right here.
Oh yeah.
So there.
Oh, okay.
Okay, and then my ground wire comes in up on that from outside up there, and you can see I've got it there's a Burndy connector up there as well, where I've got it all grounded, or I should say.
What kind of connector is that you're saying, Peter?
It's called Burndy.
Burndy. That's to go into the Romex wiring?
Well, not Romex.
Or whatever it is.
It connects two pieces of copper together, doesn't it?
Yeah, it's actually the manufacturer's called Burndy, but another name you might go by would be a split nut, split bolt. But if you go up to Home Depots or the Ronas of the world and you go in there, their electric side, I'm sure they'll have a Burndy connector.
That's for tapping into house wiring, essentially, right?
It's to connect two pieces of wire together, two pieces of copper wire together. Yeah.
Because what you're doing is you got a wire going along like this, and you're going to take your wire and you're going to put it here. You're not going to want to cut this other one.
Right.
You put the two of them in parallel like that. Then you put your Burndy connector will then go over top like that, and you put the nut in from underneath over top, and that clamps it together.
Yeah.
Right. But that's the ground wire.
As soon as you see it, you'll see it.
Yeah. Okay. Never heard of it before. That's all.
Okay.
You never asked me.
Yeah, Peter, I understand what you're saying about having two different grounds and its danger, beside that. I perfectly understand. So maybe my dumb point is why have this RF ground separately? Then attach everything to the house ground, right?
I think a lot of people want to put an RF ground in because they're close by, because I think it also helps with noise, reducing your noise. You also want to ground your tower. You want to you don't want lightning to come into your house to find the ground path to that ground rod, that kind of thing. So speaking, you're bringing your ground rods. I have my tower bonded to the ground wire before it comes in to the house.
Okay. Okay. Got it.
Yeah, I started when I started in '92. I just had an FT102 in my first radio, and that's when I put the ground rod outside the wall and connected to the back of the radio, and I've always had that. So that's how I started. Later on, I put the tower in, did the best I could to. When you do a tower, you're supposed to put 3 ground rods 10 feet away from the tower, equilaterally. I just can't do that. I don't have the space. There's no way. So I did the best I could, which is a ground rod directly below the tower, and another ground rod about 10 feet away in the flower bed, and another ground rod 10 feet further away, with a wire running from each ground rod directly to the same point on the tower. The best I could do.
Oh, no, I didn't do that. No. I put 2 ground rods down 10 feet apart. If you go any closer than about 10 feet, then you're wasting your time. But so my outer ground rod, the one that's further away, goes to the second ground rod and it is bonded there and then carries on to the tower. It's only one connection going back to the tower, or one lead to the tower.
Okay, you did it differently. I have 3 wires, one going to each ground rod.
I don't think that would be as effective in reducing the ground resistance, so I'd have to think about that for a while.
I'm not going to change it.
Maybe
It is what it is.
And none of us have a megger to go out and measure it anyway, so there you go.
And it's my radios all survived that very, very close in lightning strike. You saw the flash and you heard it instantaneously, and it was a very bright flash. I was sitting in my family room, which opens onto the deck, and there's a thunderstorm going on. As soon as I saw that, I poked my head out to see whether my tower was still there, and everything was still there. No problems with the radios at all.
See, the reason why we hook it in sort of like series is that goes back to my days as an electrician. If the inspector measured your ground system and didn't like it, you would be forced to drive another ground rod to lower the resistance, right? And you would hook it. It would be another 10 feet away, and that ground rod would bound to that same ground rod, effectively paralleling the two ground rods. So that's the theory. Anyway, it's whatever.
It seems to work, and so far so good. And I haven't had a problem with lightning or radios or anything. I've never had a strike to my tower, thank goodness. That would fry everything. Doesn't matter whether you got lightning protection or not.
No, you're right about that.
Michael, Kevin has a question for you.
Yeah.
Comment? Question?
Yeah, no, I just, when that, I think we have to remember too that there's two different systems, right? When an electrical inspector comes in, he's measuring basically DC resistance, which has nothing to do with what the RF resistance is.
That's
so
right.
Even though it may be safe, you're not going to, you're not going to get hurt on AC power off the line. It still may not protect your RF stuff because the impedance may be so much higher.
Oh, you got all kinds of, you got inductance of the,
just the
inductance of the cables, inductance
yeah,
of the
unless you're using flat braided cable to bond everything, and your impedance is probably going to be high enough that you're still going to get a voltage drop at lightning frequencies.
That's right. Yeah. So you just got to hope it doesn't happen.
It would be, but it has to be safe, first of all, right?
Yeah.
So
anyway, that's what I've done. As far as I can see, I've done everything I can, with the possible exception of this cable, which I can connect to the bottom of my tower with a clamp to the bottom of the tower and run that in along the side of the house into the basement, down to the basement floor where the water meter is connected and the utility ground is connected. Yeah.
One question, Michael, I have. You might have touched on it, but I can't recall the programming on the Arduino and all that. Did you touch on that, or?
I didn't do that. Daniel did that, and basically we started with all we wanted to do was drive the Arduino to tell the Arduino which antenna it was that's connected, and whether it was automatic or manual. So the first line says auto or manual, and the second line says on the display says which antenna, and that was the programming, the IDE programming to do that. Daniel did that with a set of loops, basically, that I think that it went through. And then when we went to go from the physical manual switch to change from one antenna to the other when you're in manual mode, he added another set of programming that basically allows that small push button switch to cycle through to pick up the antennas, to make the display say what it should for each of the antennas. But I don't know a lot about Arduino programming at all, a bit. I know enough to be dangerous. But
right. But you've got the code, I guess, if you.
Oh, the sketch. I've got the sketch.
To replace an antenna, let's say. Yeah.
So what I'm going to do tomorrow, we're going to make this change to the antennas, and so I don't have to make any changes then. But when I put up I'm going to do a fan dipole underneath the main 80 meter antenna. I'm going to have a 40 meter, which is half as long, and underneath that, I'm going to have probably the 6 meter, which is really short. So what I'm going to have to do is change the programming so that when I select, let's say 6 meters, the display says 6 meters. So that's just a matter of reprogramming it. And you know how to do that.
Changing the lines in the sketch.
Yeah, so, Daniel knows how to do that. Daniel will do that with me. Yeah.
Nice. Okay, good. Cherry, please come in.
So how do you find the ground of the house, Peter? Like, is it? I mean, I think we can find it from near the switchboard, maybe. But
You'll be a bare copper wire at your panel.
yeah, bare copper, the panel. But I was thinking, like, my shack is somewhere, the panel is somewhere.
Got to figure it out.
Okay. Okay.
I mean, if you got a finished basement, it starts to get pretty tough.
Hmm.
I think somebody, I don't know who it was, but I think somebody made a comment a couple of years ago that they actually, the same problem as you. They had the shack on one side of the house, the service to the house was on the other side, and they ended up running the ground wire on the outside of the house.
Yeah. Okay. So what I originally wanted to ask you was, the earth should be somewhere inside your, the near the house area, right? Like, I mean, just not the wire. I was thinking maybe it's located outside the house.
I think some houses, I think they use they use the copper water pipe that's coming in from the street.
For earth.
Yeah.
Oh, I see. Okay.
But
I was thinking there is a pit somewhere inside the, inside or near my.
Use ground rods, and some places use. I can't remember what mine is. I have to go take a look. Okay. But if you do go to a copper pipe, make sure you go on the street side of your meter and not on the house side of your meter.
Exactly, and that's where mine is. That's where mine is, on the street side.
Sorry, repeat again.
You have to connect your water. You must have a water meter coming into your house.
Yes.
Somewhere is a water meter. The pipe for the water meter to the street comes through your basement floor, probably.
Yeah.
So if you're going to connect a ground to it, you connect it between the water meter and the floor, not on the house side of the water meter.
Okay. Yeah, I think I've seen a wire coming near there, and I was always wondering, like, where it is going to. Yeah, okay, got it.
My main panel is outside in the garage, and I put a pony panel in when I did in the basement when I finished my basement, and that has all the grounding in there as well, and the neutrals and everything else. So it's
Okay.
So.
All right. So Jerry, that's that. Drew, you've got your hand up.
I do, and I don't want to complicate things. I was going to suggest that for 6 meters, you can use the 40-meter dipole, and suggest maybe you put a 30-meter underneath the 40 for a nice fan dipole. Just a suggestion.
Interesting idea. I already have. I hadn't thought of 30. I already have a 30-meter hamstick pair on the tower, a rotating hamstick pair at the top of the tower that rotates with the mini quad. So, but that's an interesting idea. Hadn't thought of 30. I thought of 40 and doing a 6. I already have. Somebody gave me a 6-meter dipole that I haven't ever used that I could put up. So yeah.
I had occasion to put up a fan dipole for 10 through 20, and I put 15 in it, and it very nicely matches on 12, 17, and 30 as well.
Oh, neat.
Just so happens. Yeah, I was just lucky,
Yeah.
Anyways, just a thought.
Yeah.
Okay, so we're going to move this along now. We're going to enter our roundtable part of the evening's meeting. But first, a good evening to you, Al. Thanks for joining us. Better late than never.
Oh, thank you. Yeah, just got back into the house, so couldn't make it on time, but better late than never.
Yep, that's my motto. So, all right. Michael, I will give you a pass on saying what you're up to, because you've been up to getting this presentation ready. So once again, thank you for that. Hopefully the people that missed the meeting are able to catch that on the reruns when you get syndicated. So, all right. unless you have anything else that you would like to bring up.
No, I will say for the record that in terms of the backplane project, I have at least thought about building an audio amplifier. I've thought about it. I haven't done anything, but I thought about it. That counts, right?
Sure. Yeah. I mean, hey, sky's the limit. Just don't over-engineer things. That's all, right?
Well, if you don't over-engineer it, then it's not worth doing.
Okay,
Very good.
Touche. All right. So thank you, Michael. Cherry, you're first on my screen here as far as the round the clock order. So let us know what's going on. And by the way, if you want to talk about grounding, we can talk afterwards. I ground over Wi-Fi, and I can explain how I do that. So maybe later we can talk. So, I think it's up to code.
Yeah. Okay. I don't have much going on. But, the last few days back, what I was doing, I can probably get into it a little bit. So I was, trying to repair my son's laptop, and I was successful in that. That same laptop, I used it over 5 to 6 years, and I passed it to him, and the fan was gone, so I repaired it and did a little bit of repair stuff with with his laptop. So that's a kind of homebrew come repair which I've done. Outside of that, last week I've been to the Hamfest at Ancaster, and it was nice. Got a couple of books which I got it from there, from which Peter asked to do something, right? I plan to do that. A few nice projects from an old GQRP book, and I got a few other things like this buddy pole, small chalk balloon, I think. So from Mike, actually, MKX, and a few other stuff, mostly books. Yeah, I got this nice book from there, which I can show. This is a pretty good book, Radio Handbook, 23rd edition, William I. Orr. Perhaps most of you might know this author. And I was attracted to this book. Pretty good book, I think. A lot of good reading inside of this. And the week after, this weekend, off to Kingston, coming near you, Peter. The Kingston Hamfest is October 18th, so looking forward to that. And that's the next target. But otherwise, keeping very busy on the job. So these are weekend activities. Usually, I take a book before I sleep. Spend at least half an hour to 1 hour on this or any other book. Definitely, there is a good lot of energy you get after reading a book. You get more interested with the radio stuff and so on. Sometimes it's also good to go back to basics. Read through it, and it also gives you different perspectives. From my opinion, going back to basics is definitely helps a lot. So that's what I've been doing. Nothing much on the homebrew side the last 2 weeks. And I think it's going to be a very busy season coming at work. So probably busy until Jan-Feb. That's what I see. And most probably I'll be going to all these, the last few Hamfests coming up, right? October, and that's at Kingston. And perhaps there is one more, and that's it for the year. So I do not want to miss that Hamfest. So that's all what is happening on my side. Thanks.
Okay. Thanks very much, Cherry, for the update. You're amassing quite the library there, so you can be the reference library for the group someday. So, official librarian. Okay, Drew, what's going on up in your neck of the woods?
Well, nothing really earth-shattering. A while back, I bought a DMR radio, an R3TD, I think it's called, or TH. Anyways, it's from Retrievus, nice radio. Set it all up, made myself a little Pi thing so I can go to the internet. It's kind of interesting, but I'm not really thrilled with it. I'm about to change its firmware, and this is where it gets gutsy, is I can change it into a DMR radio that also works satellites with an onboard satellite prediction software package that actually displays on the screen as the satellites are coming over. You get a target that you can point a handheld Yagi at the satellite. So that's what I've been looking into. It's a little scary to blow the brains out of the radio that you just bought and put in a completely different firmware. Even if they recommend it, it's a bit scary. But that's one of the things I've been working on.
Nice. Very good. Yeah, they had a booth at the Hamfest that Cherry and I were at a couple months ago, the Redivis people. So
yeah,
they seem to be coming out with a fair amount of gear these days, and I'm seeing I guess I'm on their email list. Maybe that's why it seems like they're very active promoting to the amateur radio community. But there you go. What do you think of the quality of the hardware, though?
Oh, good. Oh, yeah. No, it's a solid piece of kit. One of the fellows in our Saturday morning's breakfast put me onto the TID radio, the H3, and I did buy one of those. And it's a very robust, well-built, metal-framed radio. And this one comes across exactly the same way. It's got a good heft to it and very good quality. The programming is a little different, but like the TID radio, you can do by Bluetooth off your phone, which is kind of cool. But the RT3, it uses its own version of the old Bofang dongle, but you can't use the Bofang. But you cannot use the Bofang dongle. You must use theirs. Okay, and their software. Okay, and it's it's a little clunky, but it actually works pretty well. You can do both standard analog, UHF and VHF, as well as digital. And the digital is a whole experience. Like after you spend a month playing around with it, you just want to kind of get it working. So once you get it working, it's kind of like listening to worldwide 2-meter nets.
Right.
That's really what it's like. I can't say it's overly thrilling. I think it would be pretty. It seems it's well occupied. Like there's lots of people there and from all over the world, and it's quite interesting that way. But you don't get long discussions or anything like that, which I was kind of hoping for.
It's like internet chat rooms, basically, right?
Yeah. It really, I'm a little nonplussed about it, but I got the radio because of this satellite thing. I thought, well, that's pretty cool. Yeah. And now I've come to the point of actually making the change, and I'm a little gutless because I'm thinking, well, if I do this wrong, I just toasted the radio.
Yeah. Well, maybe they have some option to reflash in case as long as you don't brick it, right?
Oh, yeah, no, they do. I've already had to rebuild it once because I didn't know what I was doing. But and they even suggest this software. So I mean, it's very encouraging.
Yeah, it's above board, but
nonetheless, I hold great faith in my ability to screw up, and we'll just see how it goes.
Right. Fair enough. Okay, well, you'll have to let us know how it goes. But yeah, my impression is they do cater to the commercial market, so their stuff looked pretty well built that I saw. So
it is, and it's not expensive.
Right. Good. Okay,
but buy it from them.
Right.
Buy it from their website. Don't buy it. Like I bought it directly from them, and it arrived in good time, and the prices were better, and there was no playing around with the deliveries and stuff. So don't get it off Amazon. Just get it right from them.
Right. Yeah. No, Amazon is to be avoided. Those kind of purchases. So
it is
resellers that just mark up or scam you, whatever. So
they do.
Yep. Okay. All right, Drew. Thanks very much for that information, Peter. If you're done looking up at the heavens.
Yeah, I actually have been kind of busy. I've been working. I've just about finished well, I've already gone through and done the daughter card for the superhet receiver for the backplane project, and there has to be a couple of changes there. And there's one change left to go before I order the next round of boards, and that's a simple fix, just to make sure we're on the right. We're all on the same page, so that'll be next week to confirm that. So I'll be ready to send out for the second set of boards. That seems to work well. I've been working on a couple of presentations. One that'll probably bore you guys to tears, but you're going to listen to it anyways. But that'll be in the new year. Has something to do with capacitors. I never knew they could be complicated. But guess what? I'm also working on a new radio presentation, so I've been kind of dusting that one. I've been working on that one for quite a while, so I've been going back and forth the last couple of weeks working on this stuff. When I did the DFT presentation the other week, I kind of followed up with that one, so I'll do another presentation on that, and that's really basically an audio spectrum analyzer or audio analyzer, whatever you want to call it, so to speak. So I'll just show you a quick. That's what it looks like. Still a fair bit of work left to do on it, but in this particular case, really playing with the gains within it and stuff to get the display to show something that's useful, if you will. So, but it's coming along. I made some good progress on it today, but there's still some work, but at least that's on the software side of things. I have to say ChatGPT's been a good help with it. But of course, the more I play with ChatGPT, the more I gotta, you kind of, you need to be, between me making a mistake and it making mistakes, it can be a long venture that spreads out over days, so you kind of have to be careful how you do things with it. And as if that wasn't all enough to do, through the audio project, I've started to get back into this board here as a codec board that came from 4 Days in May from Farhan a couple years ago. So I've been kind of looking at that and seeing what I can do with this particular board. Not 100% sure yet, but that was a promise we all made, that if we took the free board from them, we all had to do something with it. So I figured it's about time I'd do something. And I think that's it. Oh, the audio essay, I couldn't believe it. I blew up 2 nanos in the process of trying to get this thing going. And this one runs off of a nano for now. It's not the best, but you know what? It's a starting point. And the nano is a hell of a lot cheaper than going to a Teensy 4.1, which has been recommended. But so if anybody knows a cheap source for Teensies, let me know.
All right. Thank you very much, Peter. We got lots of plates spinning in the air, so that's good. Keeping the momentum alive. So, all right. Kevin, what's going on out in Stratford? As far as radio frequency.
Well, I'm getting back into doing the backplane power supply thing. And I realized that I've forgotten pretty much everything I learned in that KiCad course that I was taking back in June. Because I'm trying to do some stuff today in KiCad, and it's like, wait a minute, how do I do this? Oh, I don't know. It's like, why doesn't this work? Well, I don't know. It's like, so more questions than answers. So anyway, I'm just, it's been a long, busy summer. So now time to, get back in the saddle again and get this done. Get up to the speed that Peter and some of the other guys are at. So that's it.
All right. I don't know. I saw Michael's presentation. He had a KiCad, schematic up there. So maybe you can tap into his knowledge. So. Well,
it's one thing. Drawing a schematic is actually not that hard, but then you got to get the right footprints, and you got to get the right, net labels and whatever kinds of labels you're going to use. And then you got to lay out a circuit board, and that all gets very complicated very quickly. So.
Yes, it does. That's right. The only reason I did that diagram in KiCad was because I wanted to be able to do a diagram that looked right for the presentation. That's why I did it. But at that point, I knew nothing about KiCad. Yeah.
So anyway.
Okay. Right. And I think, yeah, Frank, you just blipped out of existence conveniently. Are you able to hear me?
Yes.
Oh, there you are.
Oh, yes, I can hear you.
Yeah. All right. So, what's going on down in Amherstburg there?
Do I have audio? Oh,
You
no,
know,
do I have a video?
no video. No.
No.
At least I don't see it.
I
I
don't
can
know.
see, I can see Frank.
Oh, okay. Well, so you're partially there, Frank.
Okay, at least somebody sees me. I'm still working on the same project that I've been working on for the last 2 months. And I sort of tried to put things together tonight. And I realized how much that I had learned over the last 2 months. Where it started was during a solder smoke presentation that they showed this screen. Let me see if I can bring it up here. Hang on, I got to be here somewhere. There, I can see myself. There it is. That particular dial. And I said, hey, is that ever neat? I'd like to do one of those. Well, that was the start. And after a couple of months, I've been through all sorts of learning curves. I started out with programming it with Python because I'm using ESP32. So to keep up the speed, I thought, oh boy, it's going to be fast. So I got partway with that and then realized that this one was actually programmed in Arduino, but using the ESP32. So then I bought an online book that was how to program the ESP32 using Arduino. So that was a course in itself. So everything stopped while I went through the whole program, which was very, very good. And then I got the whole thing kind of working with, if you just see the top with the frequency there and the two added places for lower sideband and then N6 QW's code. Well, I put my code in there, but the way I'm going to do it, this is going to be the band that you're on, starting with 40 meters. So I got that far. I actually got that box. I did that, and I got the numbers in it, and I got the two comments on it. Now where I'm a little stuck, or it's beyond me, is this curve here, which is the dial. And the idea is the line stays on there in exactly the same position. And as you turn an encoder, so these numbers will turn. The lower one being 0 to 100, and then it clicks over the top one. So if you turn an encoder, this whole thing will dial just like an analog dial would be. That's where I'm having lots and lots of problems. So mostly with libraries, that it takes quite a few libraries to put this thing together. And I'm finding problems trying to compile a library. I sort of thought maybe if they published it, it would be perfect. Not that way. Anyway, it's still on a breadboard. The Gridboard is here. And if I ever get working, I'll maybe put it in a case, or I'll try the KiCad. The other thing that was a learning curve was Chat GPT. And I got really involved in that, and it just caught me. Holy mackerel. It can do that, and it can do that. And I got it to even write Arduino programs. So, and they work first time. So that's what I've been playing with, and it's still a lot of work and a lot of learning has gone into it, and I suspect I'm only part way. So I'll continue on and do the rest of it and report each month.
All right, that's good. Hey, you know what? Always something to learn, right? And I found a lot of things that you thought were, worked for someone, they didn't work for someone else. That's just how it is. I guess whatever conditions they were using, right? It worked in their setup. Finicky things, marrying hardware and software sometimes.
For sure.
Yeah. Very cool. Peter, you had a comment.
Yeah, just a quick comment to what Frank was saying about ChatGPT and the software worked first time or the coding. I wasted about a day and a half with coding with ChatGPT over the last until today. And what it was I was looking at my spectrum, at my audio spectrum analyzer, and I could see the primary frequency, no problem. And I could see, when I changed it, it would go up and down. But the lower frequencies, the harmonics or, some of the other noises down there was very low. So I went through, like I say, a day and a half with ChatGPT on how to scale differently and add this, do this, and all that kind of stuff. And then, I don't know, maybe it was about 4 o'clock or 5 o'clock in the morning when I woke up and rolled over and all that kind of thing. A thought occurred to me. What I was using was an input from my SIGGEN. Sine wave, pure sig. It's a pretty good SIGGEN. There's not that many harmonics and all that kind of, the noise bar is a bit low. So I thought to myself, oh my God, that's why it's not, and because none of the scaling's working properly because it just isn't there. So of course, this morning I go down after my coffee and I try it out, and sure enough, and plug it up to a real audio source, and there it all is. So it just shows you got to be careful what you ask of ChatGPT, or make sure your end of things is clean.
Right.
I'm surprised they didn't suggest it to you.
It did get to the point where it was suggesting I should be switching to a Teensy or things like that. But anyway.
All right. Okay. Thanks again, Frank.
The
journey. And okay. And Al, you are the last person on my screen here. So what's going on radio-wise in your world, if anything?
Not too much, actually. I'm still renovating the basement and the shack. So the interior and the lab are out of commission now, but the mobile's working. I did get my recent copy of Sprat, and there was an ad in there for the was it the Z-BitX? And okay, I bit, so I ordered that up. So it's fully assembled. So quite an interesting little radio, fully loaded with software, does all the modes from 80 right through 10. So I expect to see that within the next week and a half. So when I get it, maybe I'll tell you all about it, do a show and tell. But I guess my wallet was burning a hole in my pocket, so I bit. I had to buy it. Anyhow, that's about all I know right now. Life is good and proceeding in a forward direction.
I don't know if you caught if you were on the mixer from a couple months ago, but we actually had a presentation on a fellow ZBitX experiences. So you might want to watch.
A couple of months ago, I was in the hospital, so
Oh, right, true.
yeah,
Okay.
I didn't check in. So
yeah, well, if you watch the recording of the August mixer, you can get a little preview of
I'll go look that up.
who did a presentation to us. So yeah, might
good.
be worth a while.
Super, thank you.
Before it arrives. So yeah, good stuff. All right. Well, I think we are 9 o'clock on the nose. Pretty much at our usual time. So unless anyone else has anything they'd like to discuss, I want to thank you once again, Michael, for the presentation and talk you did to us this evening. We will be back same time, same channel, October the 15th for our regular meeting. I haven't actually looked to see if we have, I presume, Peter, we have a something lined up.
Yeah, Michael's going to talk about antenna modeling, I believe.
Yep, that's right.
Yep. Okay, great. All right.
Peter, I think it was you were asking about the details of the switch on the roof, or was it Cherry? I found the presentation, part of the presentation that shows that. If somebody wants to watch it, I can put it on. I can share my screen and show it.
No, I don't think it was me.
Was it Cherry? I forget.
Do you have is it something you just wanted to show?
Somebody was asking the details of what the external antenna switch had on it, what it came with the kit.
Oh, that was me.
Oh, was it?
Yep.
Okay, I can, if you want, I can show you that.
Right. You were searching for your original slides.
I found it. Yeah, I found it.
Yeah.
Okay, you want me to show it?
Sure.
Okay, hang on. Here it is. How do I get to it? Here. Yeah. So let me go back here. Okay. This is the schematic of the thing that's on the roof, and it's got 4 terminals. It's got a total of 6 terminals, 7 or 8 or whatever, with a bunch of relays, and each relay has a back EMF diode on it, and there's the antenna connections themselves. And okay, this is what the board looks like when you buy the board from Far Circuits, and it's whatever size it is, and it's got the 6 output positions and the terminals and the 6 relays underneath, showing us the rectangles, and the diodes are here, and connectors and whatnot. And this is what it actually looks like as it comes to you. And I think but I had to put, this is after you put the connectors on. You just solder the connectors on to the board, solder the relays in place, and solder the back EMF diodes here. And I think you also might have had to put the switch terminals.
So anyway, it does come with relays, or it does not?
No, I had to buy the relays. I had to buy everything. I had to buy the relays and the SO239s.
Right.
Mount the relays, the board. You get the bare board. These connectors are on the board. The diodes are not. You have to put the diodes in yourself.
Right.
But the footprints are all there. Huh. So here's the box, the aluminum box I bought somewhere, probably from Sayel or something. And what I did how I was talking about how I got this thing to work, I actually got a piece of thin aluminum and mounted the SL239s on it. Then I used that to drill the holes and with Greenlee, I think it was. And that's how I did it anyway. And that was a template I made up. Yeah, and that's what I wanted to show you.
Right. Okay. Yeah, very good. Yeah, I think Cherry was interested in the enclosure as well as the hardware you had surrounding it, so that's good.
And as far as I know, those circuits, that Far Circuits, is still around, I think. Anyway, yeah.
Okay. All right. Well, I appreciate that. Thanks very much for digging it out. And all right. Well, on that, 7-3 all. Have a good evening, and we'll see you in a fortnight.
Yeah, very good meeting. Thanks, guys.
Yep. Thanks for running the meter. Thanks for running the meter, Eric.
Yeah. Hey,
okay. Good night.
Good info.